Tryna keep doing it right when you on my mind, cause you are my baby. Promise I'll treat you like a lady, and I won't do you wrong, cause this is our first song.
深夜東京の6畳半夢を見てた
The group conducted a Zoom meeting to discuss about the division of parts, as well as the values to be placed in the table, followed by conducting the PhET simulator in order to record and complete the given table. After agreeing to the values 10, 11, 12, 13, and 14 for the resistances 1 to 5 respectively, a value of 24 volts was agreed upon to be the constant value of the voltage. Upon conducting the PhET simulator, the yielded results of the values for the experimental current are 2.40, 2.18, 2, 1.85, and 1.71 for the trials 1 to 5 respectively. Next, we have solved for the theoretical values of the current and voltage using the Ohm's law I is equal to VR, or current is equal to voltage times resistance. The theoretical voltage yielded the following results: 24, 23.98, 24, 24.05, and 23.94 for trials 1 to 5 respectively. And as for the current, the values are exactly the same as that of the experimental current. As we have finished the table, we will now move on to discussions, observations, analysis, and parts of the experiment. Thank you.
Ohm's law was first explained by a German physicist, George Ohm, and it states that the current flowing in a circuit is directly proportional to the applied voltage and inversely proportional to the resistance in the circuit. The equation for this is V equals IR, wherein V is the voltage, I is the current, and R is for the resistance. So as for the results that we can see in the table, we have a decreasing value of resistance with a constant value of voltage, along with a decreasing value of current. While for the theoretical voltage and theoretical current, which followed a computation wherein the value for the theoretical voltage was sought by multiplying the current and the resistance, and for the theoretical current, the voltage was divided by the resistance.
As we all know that Ohm's law describes the relationship between current, voltage, and resistance, our group observed that the values for the current for both the theoretical and experimental columns of the experiment decreases as the resistance increases, even if the voltage was at constant or solved for, which corresponds to the Ohm's law. However, we noticed that the theoretical voltage did not have a definite pattern of increase or decrease. Overall, the statement as the resistance of the circuit is increased, the current of the circuit decreases can be observed in this experiment for both experimental and theoretical trials.
As for our analysis, we have analyzed that in our data, it shows that the higher the voltage, the higher the current will be, meaning that the voltage is directly proportional to the current, which is what Ohm's law states. This means that when the voltage increases, the current will also increase as long as the resistance is the same or there is no resistance at all. In the table shown, we have come up with an increasing value for the resistance and a constant value of the voltage, which resulted with a decreasing current, This means that the higher the resistance is given in a constant voltage leads to the decreasing value of the current. Same goes as with having an increasing value of resistance and a decreasing value of voltage. The current also leads to a decreasing value of the current. This only means that the higher the voltage, the higher the current, and the lower the voltage, the lower the current.
Good day, everyone. So for our conclusion, while the resistance value increases, the electric current on the other hand decreases. In other words, the resistance value is proportional to the current value. The potential difference can be found by multiplying the resistance and the current value. The current flows from positive to negative, and regardless of the resistance value, voltage, and electric current, the electrons flow from negative to positive. The current and the electron speed are both dependent on the resistance and the present voltage, and the values for both theoretical and experimental are almost the same. So in this experiment, we conclude that the Ohm's law was proven.
The current is proportional to the voltage. When a resistance reaches a stable state, it is said to be following Ohm's law. The resistance is represented with the symbol for ohm. To grasp Ohm's law, imagine a liquid circuit in which we have a pump, which has a battery that has a voltage, which is then flowing and meeting resistance. The crucial part of Ohm's law and resistance is that the higher the resistance, the less it can flow out. As a result, depending on the voltage and the size of the resistance, the current can flow through the resistance in different ways. We can see this experiment that the voltage values are dependent on the values of the resistors. The higher the resistor values, the greater the electromotive force values. This demonstrates that the voltage range and resistor value are linear to each other while the value of the current is perpendicular. Based on the data collected, it confirms that the experimental value of the resistance was pretty accurate, and that the experiment was successfully accomplished. This is similar to the example of the linear current. The more the resistance, the bigger the resistance is, the less it will flow. Ohm's law have been confirmed in this laboratory experiment because of the relationship between current, voltage, and resistance with the information collected.
So I'll give it a shot, give it all that I got.